Hello, I'm Facundo Parodi. Thank you for attending this talk on machine learning and computer vision. I'm a machine learning engineer at Tryolabs, an Uruguayan-based consultancy company. We have more than 10 years in the industry, and in all this year we have served more than 100 clients from different areas such as retail, medical industry, or the oil industry, among others. Often using computer vision as an integral part of our solutions. The plan for today is to go over some general concepts involving the development of any machine learning project. First of all, we are going to see what machine learning is, what kind of problems we can solve with it, and most importantly, which steps we need to take to actually solve one of these problems. Then we are going to dive into the subfield of machine learning called deep learning. Particularly, we are going to see what a neural network is and how does it work. Finally, we are going to take a look at how we can use all of this to build a system that can understand pictures, and take a look under the hood of convolutional neural network, certainly the building block of today's cutting-edge systems. But before we start with this talk, I want to ask you a question that the internet has been trying to answer for many years now. What is a cat? And I know, this sounds like a silly question, but I want you to really imagine how a cat looks like. You're probably imagining something like this. Small animals, covered in different patterns of fur, with two pointy ears on the top of their heads, two round eyes, and a sleeping disorder that makes them sleep the entire day except between 3 and 5 a.m. You know, a cat. But isn't this also a cat? Here we only see one eye and one ear, but you probably don't have any problem identifying this as a cat. How about this one? Even when it doesn't appear to have fur, we are able to identify it as a cat, and maybe even more precisely as a sphinx cat. Before you say, okay, this is too easy of a problem, we have clean center images of their faces, take a look at these other two examples. On the first one, we have a contortionist cat covering part of its face. And on this other one, we don't even see the face. We don't see the eyes or the fur. We don't even know if it's facing forward or backward. But again, we don't have any problem at telling that, okay, these images have cats on them. So here we have just 4 examples of common problems we may encounter when trying to build a system that understands pictures. Maybe a part of the object we are trying to identify is hidden behind some other object. Or we could have many different shapes, colors, or patterns that characterize the same object. They could appear contorted, deformed in any way, maybe just by being closer or farther from the camera. We may also need to deal with different lighting conditions that change how our objects look like. So even when for us, identifying cats on images seems like a simple problem, it actually presents a lot of difficulties when we think about it.